Isn't it the 27th?
Yeah.
Hey, let's keep it civilized. Wrong
All right. Okay. Today is the 27th.
Yes, it is.
I was
Okay.
getting in the way though when you.
All right, and this is more fun
Wait, no.
with rational expressions.
Didn't we already have that title?
I'm not sure.
I just started titling them math.
Okay, now, the first rational expression we looked at was f of x equals 1 over x.
Is this from 2 days ago or just in general?
In general. I think it was 2 days ago we looked at it.
I still have to watch the video.
Monday.
Thank you, Joe.
And this is the one that passes through 1, 1, uses both axes as asymptotes, and passes through -1, -1. Okay? This is the parent function. Now, if you remember how functions work in general with our f of x equals a times f of b x minus k plus h, with all of our thing that acts kind of like slope, but only once, thing you divide all of the x's by, counterintuitive shifts left and right, and intuitive shifts up and down. On this function, you wind up with something like this. F of x equals, I'm going to leave out b because, well, no, b could show up. I'll take that back. You wind up with a times the function can go on top, b times x minus k is on the bottom, and h is outside of the function. So you can use this combined with this information to graph certain types of rational functions. For example, if the function is, I'll start the example up here, f of x equals 1 over x plus
Do you mind
2.
if we periodically take pictures of the board?
Pardon?
Do you mind if we take pictures of the
Not at
board?
all. Not at all. So f of x equals 1 over x plus 2. Is that plus 2 inside or outside of the function, what the function's doing?
Outside.
Outside. Is it intuitive or counterintuitive?
It's intuitive.
Intuitive. Up or down?
Wait, is
Down. Up,
intuitive
up,
a thing?
up.
No. Well, it's a thing of mine. It's not a real word.
Yes, he said it's
Counter.
K and H, and he said counter with K and
Counterintuitive.
intuitive.
Intuitive.
I wasn't sure if there was actual.
No,
So
it's not
intuitive
formal.
means nothing. I'm
It's
sorry.
not formal math.
I'm sorry.
It's okay. So if I take 1 over x and move everything up, here's the part to keep track of. The asymptotes move as well. So instead of the asymptote being y equals 0, the x-axis, the asymptote is now the horizontal line y equals 2. Instead of passing through 1, 1, it will pass through 1, 3. And instead of passing through -1, -1, it will pass through -1, 1. So this is your new function.
That's no fun. That's boring.
Think you guys can handle that?
Sorry, what's the second point?
This is the point -1, 1. All I did was added 2 to all the y values of the parent function and moved the horizontal asymptote up 2.
So, if it was 1 over x plus 2, does that mean that the vertical asymptote would have changed?
Perfect. If it were 1 over x plus 2 and it was down here, then the vertical asymptote would have changed. It would have changed counterintuitively.
Right, 'cause it's in the thingy and then.
So it would have moved 2 over to the left.
Okay.
All right. I need to give you one more parent function for this. One other rational expression I haven't shown you yet that was in, either was or will be in some of the problems depending on what you did last night. New example, f of x equals 1 over x squared. This behaves very similarly to 1 over x. It doesn't line up over it perfectly though. X squared makes a difference. it will pass over, it will pass through 1 over 1. If you're trying to draw it accurately, it will actually start to get close to its asymptotes faster. That's what the exponent does. So you could draw it snuggling up to the x and y axes even faster.
Because it's exponential?
Yeah, well, it's not really technically exponential. Exponential is when the variable is in the exponent spot,
Okay.
but it's quadratic on the bottom.
Right.
Is one way to look at it. But also, you can put negative x's in, but you can't get positive y's out. You can always put a negative in for x, but when it's squared, it'll be positive. So this one is only in quadrants 1 and 2, and when I put a negative 1 in for x, I will get a positive 1. And it does have symmetry about the y-axis. So that's what 1 over x squared looks like. Another part of the work tonight is to apply all of the various shifts to this one. So this is your parent function, and f of x can be a over b x minus k squared plus h.
So it's everything should look like that, but shifted? Or?
Yes, this can get shifted. I don't think any of the homework even uses a and b. I believe it just uses k and h. So it looks like this. The x-axis is a horizontal asymptote. The y-axis is a vertical asymptote. They move with the shifts, and these points move.
Is there a cube parent function?
There is. I mean, we can make up a million of them, but we're not going to.
I mean, like standard. It like not something that we make up. Like, I mean, does it exist like standardly?
It exists, but it's not something we talk about much.
Oh.
It just doesn't come up much. The things we bring up are things that are either find themselves on a lot of standardized exam, or someone somewhere actually uses it to do something. You may never find out exactly what.
This stuff is used.
Oh yeah. Oh yeah. I mean, my dad
I
worked
know.
as an applied mathematician. The stuff he actually used every day used to freak me. I'd ask him, Dad, who uses this? And he'd give me some actual specific answer.
Who my friend
Your
Carl
dad was like one, like
super math.
bit
He was a rare individual, yes.
Right, like you can't use your dad as an example.
But when I did, when
Why
I
not?
asked him who actually uses imaginary numbers besides electrical engineers, and he was like, "Oh, I did every day designing submarine hulls." I was like, "Really?" Who answers?
Then it goes into a flashback, and then like he tells you like a whole lot of story.
Pretty much. All right, so this should let you graph variations of 1 over x squared and 1 over x. I'll answer more questions on that tomorrow after you've tried a couple. Incidentally, everything else I told you will also work for these. All the other stuff I said about how to graph would work on graphing these. This is just easier. So that's like an Easter egg on the test. I'm not going to say do this one this way. I'm just going to give you one like this and see if you figure out what the best method is to do it.
Graph it.
Yeah, to graph it. This test will probably just be a couple of graphs. Maybe 4.
Now, when you said yeah, and what else?
That's it.
Are you sure?
That's all. Can you graph it?
There has to be a catch.
So it's gonna be like
what's
some
the-
psychograph on steroids.
Kind of like this next one. Good segue.
I don't think.
Okay, now I'm going to do one like we did yesterday, and I'm going to give you a new trick that may help you. Okay? So, may I erase this
Oh, feel
example?
free.
Mm-hmm.
All right. Now, remember, I didn't show you exactly what to do with these, but I gave you enough information, and I'll take more questions on it tomorrow. Here, I'm going to show you exactly how to do one of these. I need to pick a good one. No. Maybe.
Close your eyes. Drop.
It probably won't be what I want then. Oh, that would be mean. No, not that one.
This book's cool.
Be mean. Be mean.
It is, but you might want to pay more attention to what we're actually doing. Forget about symmetry. I don't like that strategy one. Apologize for the delay. I could make one
Say
up
sorry to
normal.
your
Okay.
dedicated viewers.
I will be, yes, I apologize for this one. We're going to do a slightly harder example than I thought, so this factoring may be more interesting than I wanted. I want exactly the same difficulty level I did yesterday, and I did not make one up. Okay, I thought I had one more. 3x squared plus x minus 4 over 2x squared minus 5x. All right?
It was just the water.
Quite all right?
Yep.
Okay, now, thank you, Johannes. All right, first thing you always want to do is factor and then start answering questions. The bottom only has one greatest common factor between them. Don't panic on the test. Always look for a greatest common factor first. Don't say, oh my god, there aren't 3 terms, I can't do the reverse foiling. What do you do instead, Jonas?
What? Oh,
I thought you were
factor. Oh, I was factoring the top first.
Oh, okay, let me do the bottom real quick. You pull out an x,
Yeah.
you're left with 2x minus 5.
Yeah.
What do you got on the top?
3x plus 4. X minus
3x plus 4x minus 1, is that correct? That will get me the 3x squared plus a 4x minus a 3x, which will get me a plus x minus 4. I think he's correct.
Wait, let's oi it. 3 minus, yeah.
Okay,
Oi,
good.
oi, oi.
Okay. Now we can start answering questions about it. First one is the zeros. The zeros are going to be x equals 1. What value of x to make that? 0.
negative 4/3.
And yeah, negative 4, x equals negative 4/3, correct.
Oh, and the zeros are only on the top.
Zeros are only on the top. To the bottom, from the bottom we find the vertical asymptotes.
Okay, so for like yesterday, there was a. I might have done this wrong, but on one of the problems, it was just a. It was like one number. It was a 1, I think. So like.
That can happen. There can only be one vertical asymptote sometimes.
No, I mean it was like just a 1. There was no variable on the top.
Ah.
So what is
Negative 1.
Yeah, if there's 1, okay, then there's no zeros.
Oh, okay.
There's no zeros because 1 can never equal 0. And then their vertical. The bottom will give you vertical asymptotes. The vertical asymptotes are at x equals 0. Now, you don't have to have either. But most rational expressions have one or the other. A rational expression has to have one or the other, but not both. Or x equals 5 halves. These are the zeros of the denominator. These are the zeros of the numerator. These will be x-intercepts. These will be vertical asymptotes. Do either of these zeros occur both top and bottom?
No.
No buttonhole discontinuities then. Glad everyone loves that term. Now,
Apple looks at me every time you say it.
Alright, that's right. Next thing we need to know, horizontal asymptote. Tell me something about the degree, top and bottom.
They're the same.
They're the same.
The constant's not. I mean, the coefficient's not.
Right. The degree is the same top and bottom of the polynomial. The leading coefficients are 3 over 2, so y equals 3 halves is my horizontal asymptote. We'll have to be very good at graphing with fractions on this. And what was the other thing we found yesterday? Was this it? Before we could start?
Slant thingamajigs?
We don't have that. We only have a
Y-intercept.
y-intercept. Thank you. We only have a slant asymptote if the numerator is 1 degree higher than the denominator.
Okay.
All right. Y-intercept. F of 0 equals undefined.
Yeah, 4 over 0.
And I should have known that because x equals 0 is a vertical asymptote. That is the y-axis.
Right.
So if your y-axis is an asymptote, you're not going to have a y-intercept. I'll make it a little bit annoying to graph. Now, yesterday I was running slow on time, so I did a quick example of how to find out where a graph is positive and negative. If you have a little more time, and I'll give you space on the test to do this, you can make a sine analysis chart, similar to what Mr. Singer had you do last year, to tell you where the graph is positive or negative, and I will show you how that works. This is tedious the first time you do it, and I'm not going to make you do it. Although I used to make kids do it in calculus, so it is a good prep for that. So here is sine analysis. Okay? What you do for sine analysis is you make a number line for each of the factors, top and bottom. And on that number line, all you indicate is positive, 0, or negative. Okay? So 3x plus 4 gets its own number line. Here's 0 on the number line. I'm going to put the values of 3x plus 4 on the bottom. And, well, all right. Yeah. I'll start with this number line. When is 3x plus 4 equal to 0?
When x equals.
We figured out the 0 already. When x equals negative 4/3, like Johanna said. So that's negative 1 1/3, right? So here we have a 0. Below negative 4/3 is 3x plus 4 positive or negative?
Negative. Wait. Oh.
Yeah.
Negative.
If I put in a number less than negative 4/3 in for x, 3x plus 4 will give me a negative number. Set the factor equal to 0 and solve for x.
But then that 3 would go away.
No. 3x plus 4 is equal to 0. Subtract 4 from both sides. Divide both sides by 3. X will be negative 4/3. That's a step for how we found the 0 over there. Okay? Now below this point, this factor is going to be negative. And if I put in a number larger than 3x plus 4, this entire factor will be positive. So if I put x values into this factor, low x values will make it negative, negative 4/3 will make this 0, anything above negative 4/3 will make this positive.
Wait, why is it the 0?
Because this is the actual value for x. These number lines are values of x. This is the actual value for x I put into this expression to make the whole thing equal to 0. Okay? Now I do it for the other fact, for the next factor, x minus 1. Here's 0, my number line. I'm lining it up with it for a reason. These are actual x values. Now, at what point on the number line does x minus 1 equal 0?
1.
Yes, when x equals positive 1, the entire factor equals 0. If I put in something bigger than 1 for x, I will get a positive number. If I put in something less than 1 for x, I will get a negative number. Okay? Now I make 1 for x, because now I'm moving on to the factors of the denominator. If I put in 1 for x, when x is 0, x is 0. The value of this factor in the number line is the same. If I put a negative number in for x, I get a negative number. Put a positive number in for x, I get a positive number. And lastly, 2x minus 5. I put in, oh, but actually, wait a minute, I'm sorry. When x is equal to 0, what happens to this whole function?
It's
Undefined.
Undefined. So over 0 here, I want to write undefined because that's how the function behaves there. Okay? Now 2x minus 5 is equal to 0. We set it positive 5 halves. So on this x-axis, I go out to positive 5 halves. 1, 2, 3 and a half. And that's where this factor is equal to 0. When 2x minus 5 is equal to 0, what happens to the whole function?
It also is undefined.
It also is undefined. And if I put in anything less than 5 halves, I'll get a negative number. Anything greater than 5 halves, I'll get a positive number. So on the bottom of these number lines, I've written the x values for each factor. And on the top, I've written what the value of the factor is and what it does to the function. Does that make sense?
Mm-hmm.
Okay. Here's why. Now at the bottom of all this, I'm going to make one more number line. And on this number line, I'm now going to label it f of x. Line up my 0.
So this is y?
This is y. This is what happens to y with all of this. Okay, the very first point I have labeled is negative 4/3. Next point I've labeled is 0. The next point I've labeled is 1. And the next point I've labeled is 5 halves. And now this took a while to set up, but we'll see if it was worth it. And some of you will decide it won't, will never want to do this. Okay?
Just because of time or because it won't work?
Just because of time. It'll always work. It's actually kind of beautiful if you get it down. Because now this is how each factor behaves. Remember, numerator, numerator, denominator, denominator, okay? Numerator, numerator, denominator, denominator, negative, 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 negative.
Why did you use a point for the negative 4/3 but then tick marks for the other thing?
Total brain farting. Absolutely no logical reason. Okay, so everywhere here on the number line for this function, this represents where both numerators are negative and both denominators are negative. So what's the function?
Negative.
Positive.
Positive. Negative times negative is positive, divided by negative times negative. So the function must be positive all the way to negative 4/3. At negative 4/3, I have a 0 in a numerator. That will make the function have a 0.
Is that a buttonhole?
Nope. No, that's just a 0. That's just an x-intercept. Because that's buttonhole, you need 0 top and bottom. I need to also have a 0 down here.
Wait, why are the positives down on that side?
Because this is what the function is doing. And if the function has two negative numerators and two negative denominators, then the function will have positive values in the same region where this is going on, over the same domain where this is going on. Okay? So if everything's negative, top and bottom, you're going to have a positive function here. Okay? Now, between negative 4/3 and 0, I have a positive on top and a negative on top, and a negative on the bottom. What is a positive times a negative divided by a negative times a negative?
A positive?
Positive times negative is
positive times
Negative.
No, negative.
negative, and then divided by a negative times a negative. So here, it's negative between these. At 0, the function has a 0 in one of the factors on the bottom, so the function is undefined. Between 0 and 1, I have a positive times a negative on top, which is
Negative.
certainly positive times negative, and then over a positive times negative. Negative. So it'll be negative times negative divided by negative.
That's positive.
It's going to be positive in between. Okay? At 1, I have a 0 in the denominator. So what's the function doing?
Undefined.
It's in the, I'm sorry, you answered the right question. But at 1, I actually have a 0 in the numerator.
0.
So that's a 0 of the function. Between 1 and 5/2, I have positive, 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 negative.
So negative.
So negative. At 5/2, the function's undefined because my 0 is in a denominator. And then from 5/2 up, I have a positive times a positive on top of a positive times a positive.
Negative.
Negative, yeah, that would be. Okay, now that was time consuming.
Yes, it was.
Won't lie.
But it's worth it.
Is it worth it? Well, let's see how much faster it makes.
Well, I mean, probably, since we only have 4 graphs in the test.
Yeah?
I mean, it all amounts to nothing in the end.
What? Yeah, so we have 4.
Now, Kath, you may want to duck. I apologize. I don't know how wide angle the lens is. Okay, now, the advantage to doing the sign analysis is now on my graph, I don't have to run back to the original function and plug things in. Okay, let's see. 1, 2, 3. 1, 2, 3. Don't know about the y values very much. I could plug a few in, but okay. At negative 4/3, 1 and 1/3. Here's a 0. My horizontal asymptote is at y equals 3/2.
Isn't it 4/3?
No, that's a 0. That's negative 4/3. That's this.
But where
That's
are you
this
getting
x-intercept.
your negative 3/2?
I'm not. It's positive 3/2, and that is my horizontal asymptote from the leading coefficients of x squared, 3x squared and 2x squared. Okay? The y-axis is an asymptote, and 5/2 is an asymptote. Over here, 2.5.
What's the horizontal asymptote there?
That's y equals 3/2. I can write that more clearly. And this is at 5/2. Okay, that's what, and then my other 0 is at 1. Okay, now I know that the actual function is positive from negative 4/3 and heads to that asymptote. I know it's negative in between negative 4/3 and the y-axis. I know it's positive between 0 and 1, and it has to be coming down from this asymptote. And then I know it's negative. Bless you.
Bless you.
Wait, 1 is a 0, right?
Why is it crossing the asymptote?
It can cross the horizontal
Make it
ones.
stop.
And then,
Wait, is that a negative ballerina?
sort of, if I'm doing this right, double check me on this. Because from 0 to 1, it has to be positive. At 1, it has to be 0. Then it has to be negative until 5 halves. And now it has to be positive up here and snuggle up to both of these asymptotes, right? The only way it can be positive after you get past 5 halves and snuggle up to both of these is if it looks like that.
You didn't put points. You put.
Yeah, I didn't have a point up here to put in. Do you think that sine analysis sped up this part?
Yeah.
Okay, did it speed it up more than what we did yesterday where we drew all the asymptotes and zeros and then I kept running back and plugging in numbers?
A positive thing for this, and a positive, get it signed. But like, that was really bad. For partial credit, if you don't graph it correctly, it gets you more partial credit.
Very smart, Johannes. This actually lets me see where your mistakes are more easily, and I always give more partial credit for that. Ramsey, did you have your calculator? And we're gonna, yesterday you were checking these on the calculator. Do you have that handy?
Is there a
Pretty
point
confident
up
about it.
there?
Pardon? There is no point up there. Up here's the tricky part, but there's only one way. Think about it. An asymptote is what the function has to snuggle up against, right?
Right.
If it's going to snuggle up against this asymptote and this asymptote, it can either be up here or it can be down here. But we know it's always positive after 5 halves, so how can it snuggle up to both these asymptotes and always be positive? It must be up here in this corner.
It'd be positive either way. Oh.
No, if it snuggled up to both of these, it would have to be negative
At some-
somewhere.
So there
And
has
it would
to-
have to have another 0 after here.
So there has
And
to
we know it doesn't have either of those. We know it's never negative and has no more zeros after this, so it can only be up here.
Bellevue.
Yeah? Okay, pause that, Albert.
No, I'm kidding, I'm kidding.
Alright, so we have double checked, and this is basically what it looks like. This shape here is basically a reverse ballerina, but I'm pretty sure this is off. The rest of it's pretty good. The sine analysis, like Johannes said, it's a great way for me to see your thinking and give you more credit, unless you do a horrible job here. But it also, when you're done stacking them up, it really helps you just go, oh, positive 0, negative undefined, positive 0, negative undefined, positive.
Wait,
Yes?
how do you know where to graph the 1? Like when x is 1?
When,
How do you know it goes down? Oh, okay.
well, we knew this was a 0, and we knew it was positive above this 0, positive, excuse me, to the left of the 0. We knew it was negative to the right of the 0, and we knew it had to snuggle up to the y-axis as a vertical asymptote. We knew it had to snuggle up to x equals 5 halves on this side.
Okay.
So this is really about all it could do. And as I mentioned when I first introduced horizontal asymptotes, they can be crossed near the origin. How close to the origin depends on the function.
Wait, what?
A horizontal asymptote can be crossed near the origin.
Why?
They don't, well, these are functions of x, right? So a function of x means there are certain rules about x, like a vertical asymptote, an x value is where the function absolutely cannot exist. That's just not true about a horizontal asymptote.
Right.
A horizontal asymptote is a tendency as x gets very large. It's not a break in the domain.
Right, because there's kind of no need for...
Yeah, it can,
Or, yeah, there is.
it can exist at any y, it just can't exist at any x.
Yeah.
It's very weird that way. Alright, if you can handle this example and get quick at these, you're golden.
How long did that take?
No, this was the hardest one. A lot of them don't have that many factors top and bottom. Okay, let's kill it and give you some time.